I'm Pete.
I'm Stephanie, and we're here to introduce you to the 2023 finalists in the Cool Parts Showcase, our contest looking for new 3D printed parts to feature on the show. Thank you to everyone who sent in their cool 3D printed parts. We had so many to choose from, and this was not an easy decision.
So we're going to share with you all of the finalists, but you are going to pick the winner. The winning cool part in each of the three categories is going to be determined by audience voting, both online voting and voting in person at Formnext Forum Austin.
All of the finalist parts will be on display at Formnext Forum Austin. That's happening August 28th through 30th. So make plans to come to the event, come see these parts in person, and check out the Cool Parts Showcase on the exhibit floor.
So without further ado, here are the 2023 Cool Parts Showcase finalists.
First up, we'll be looking at parts in the Best Bespoke Solution category. Here we are looking for 3D printed parts that solve a unique one-time challenge. First up, the Active Comfort Prosthetic Liner. This part sits in between the prosthetic limb and the wearer's skin, so it has to be durable, flexible, comfortable. This one was sent to us by Advanced 3D, and it was created based on the scan of a transtibial amputee who's a very active runner. It was 3D printed from flexible TPU using multi-jet fusion, and the wearer was able to increase his training mileage and actually even ran a full marathon using this device.
Developed by Advanced Engineering Solutions, here is a tailor-made bone replacement. So this femur is for a patient with bone cancer. It was customized to the patient, tailor-made for their geometry based on a scan, and it will be 3D printed in titanium using laser powder bed fusion. The gyroid lattice design promotes integration with natural bone, and simulation was used with the actual patient's weight to assure that this implant provided exactly the right stiffness compared to natural bone.
Next is a heat exchanger for rocket engine testing. This part was used in the testing of Launcher's E2 regenerative rocket engine. It is one monolithic part, and its purpose is to capture heat from the engine pre-burners to preheat the fuel during hot fire testing. It's made from GR Cop 42, a copper alloy that was created by NASA for regenerative engines. It comes to us from Velo 3D and was made on the company's Sapphire platform for laser powder bed fusion. The heat exchanger was successfully used in testing, allowing Launcher to carry on and go forward with its design.
From additive manufacturing provider Ricoh 3D, these feet were customized for a specialized machine that needs 12 of these feet total. Each of the feet supports 120 kilograms, and the feet were originally designed to be steel, but 3D printing them from nylon instead saved weight, saved lead time, saved cost.
This custom gasket plate was made for a Clydesdale named Frida who had a canker in her front foot that wouldn't heal. The owner was basically told there was nothing more that could be done for her, but 3D Squared traced her hoof and created this gasket as a way of holding the medication in place. It was 3D printed from a flexible TPU filament and features lattices with variable stiffness similar to the midsole of a human shoe. And it worked. The gasket held the medication in place long enough for the injury to heal, effectively saving this horse's life.
Now for our production category. These are end-use parts in serial production through additive manufacturing. Our first production finalist is a 1 million order quantity part being made through 3D printing. Merit 3D is making this part for Adhesives Technologies. The part is a hanger connecting a mixing nozzle to an epoxy tube. Merit 3D redesigned the part so that it could be 3D printed through vat polymerization without supports, and the company is now producing this part in batches of 400 at a time at the rate of 24,000 pieces per day.
Next up is a variable resistance trim stack. This part sits inside a valve where an actuated plug moves up and down to control the flow through the stack. This part was sent to us by Baker Hughes, who previously used to make these parts by drilling holes into sheets of metal, stacking the sheets together, brazing them together, but now they're working to convert this product line to additive manufacturing for the benefits in assembly consolidation and also ease of manufacturing. This part was 3D printed from Inconel 718 using laser powder bed fusion. The company has already delivered more than 60 of these trim stacks to customers in more than 20 different designs.
KAV makes this personalized bicycle helmet, which is tailored to the measurements of each individual rider's head. This mass-customized helmet is 3D printed through fused filament fabrication using a custom polycarbonate material provided by Jabil. And the helmet uses a special hex honeycomb design that has been validated by the Consumer Product Safety Commission to provide superior crumple zones in the event of a crash.
The Link bracelet was created as a collaboration between jewelry line Lace by Jenny Wu and 3DO, the AM company who sent us this entry. The bracelet is made entirely of 3D printed stainless steel links that hook together without needing any fasteners or additional parts. It is fully customizable in terms of the size by swapping out the different link sizes, and is also available in a variety of finishes. The links are made with 3DO's intelligent layering process, a 3D printing process where layers of metal powder and binder are shaped through milling and then sintered to their final form. The bracelets have been available for sale since February 2023.
These footrests are replacement parts for Alstom high-speed rail cars. Public transportation is a demanding environment. Parts like these need to be replaced. Nexa 3D, using material from Henkel Loctite, has manufactured more than 100 of these footrests now that are in use in trains. The resin 3D printing allows for strong, low-cost production, and passengers don't even know these parts are 3D printed.
Our last category is proof of concept. Here we're looking for cool 3D printed parts or applications that are not yet in production. This pre-assembled turbojet engine was developed at Technion, the Israel Institute of Technology. It consists of two self-supporting concentric parts, a rotating shell structure inside a stationary housing. This turbojet engine is 3D printed all in one piece. There's no assembly required. It is a fully moving, working engine almost right out of the printer. It is made from Inconel 718, printed on EOS equipment, and a design like this going into production would very much simplify the process for making these engines and also make them cheaper to produce.
Security company Azalon uses robot dogs from Boston Dynamics for remote surveillance, but the robot dogs can slip or fall on the ice. Azalon turned to Dive Design for the snowshoes that solve this problem. Dive used Exstellar's carbon fiber filled polypropylene material to 3D print the shoes durable enough for the metal traction studs to be heat pressed through the tread design.
The CoSonus speaker was created by Cognitive Design Systems and developed with the company's own software for generative design and manufacturing optimization. It was 3D printed from polypropylene using the SAF system from Lattices, and it was made all in one piece. So this is a single 3D print that can work as a functional speaker.
Students at Virginia Tech made this generative designed quadcopter drone body 3D printed all in one piece. Different colors show the different deposition paths. The white main body shows the 3D printing in Z levels. The black arms show the printing that was done in an off-axis configuration. And the red conformal printing shows additional material added in regions of stress. This quadcopter drone has been demonstrated to carry a 1 kilogram payload for over 15 minutes.
This hydraulic manifold is for a pressurized rescue module that's used by the U.S. Navy in the Submarine Escape and Rescue Program. The manifold controls critical operations such as hatch opening and closing, and it's a replacement for a part that was previously made through other means. It was redesigned and optimized for additive manufacturing at Penn State University, along with several other project partners. And it is 3D printed 17.4 stainless steel made on an EOS machine. It could go into production as early as 2024. Thank you again to everyone who sent in parts, and a big congratulations to our finalists. You can learn more about these parts at thecoolpartshow.com, and again, make sure to come see them at Formnext Forum Austin.
We will announce the winning cool parts at Formnext Forum Austin on the last day of the show, August 30th. We hope to see you there.
Thanks for watching.